set of monitor 2, which is the display up here. So you can switch them.
Still is over there, but maybe. Yeah, that's what I just did. Where's my mouse at? Oh, it's over here. Seriously? Are you shitting me? PowerPoint sucks.
All right, just do it like that.
Do it like that?
Yeah. Just expand it. There you go.
All right, whatever. F5? Yeah, it keeps doing it. Well, whatever. Yeah, it does it on the wrong screen. Whatever.
And we've tried to swap them, and it just doesn't.
Having enough technical difficulties with this stupid laptop. All right, this will be fine. You guys can see that, right? Demo may become challenging. We'll see. All right, well, welcome everybody to our talk. Apologize for the delay. We're having exceptional technical difficulties with my laptop. We gave this talk at Black Hat this summer, and got some feedback that it was a sales pitch. So I don't know if they were in our talk or not. I don't think we're selling anything. So you guys let me know if it sounds like a sales pitch. I apologize if it does. It shouldn't be. We don't have anything to sell. So. My name is Michael Murphy, Presmike, most of you. Aaron Lemaster is my co-presenter, Sippy. We have a lot of content, so we're going to probably go really fast. And I guess if you guys have any questions, come see us afterwards. We'll try to make some time at the end, but no promises. All right, so we're going to jump right in. So RETRI, basically what happened was we both work in incident response a lot, and we found that the current methodologies that are out there for a really large-scale response didn't really work well, so we wanted to come up with a new way to do it. We found that there might be a better way to do response on a really large scale, and so put it into a talk. There's 4 separate phases to it, and it really relies on some segmentation and some technologies that weren't necessarily around several years ago when everybody started doing response. So it's sort of some new technologies that enables this, and it really helps save some money in the long run. So there's 2 halves to this talk. First half I'm going to give, it talks about the first 3 phases of the methodology, basically segmenting the networks and getting ready to do the response piece. And then the last half of the talk is phase 4, but it's also where we talk about the tool that Aaron's created. It's free, it's open source.
As of tonight, it's open source.
Yeah, it'll be released tonight. So unfortunately, we were unable to release it this summer, but we've worked through all the legal landmines, and now the tool is ready to be released. So I'm very excited about that.
Not really.
Well, so to start off, we have some assumptions that need to be made for the talk. We're talking large-scale stuff, not your mom and pop shops, but like really big networks for this to really be cost-effective, I guess. And we're talking really complex networks, not just one domain, and but possibly multiple domains and lots of different segments. Maybe it spans an entire city or country or the globe. And the last line's kind of important. Forensics. Done a lot of talks on forensics. Scott Moulton does them as well. We're not really talking about forensics this time. We're talking about just trying to get the network back up and running and keeping your users working. So we have.
Should we tell them about the booze first?
Oh yeah. So anybody who's here, there's a big jug of booze there on the table. I don't know who left it there. It's really good stuff though. So if anybody's like,
that's what we're drinking.
If our talk
Hand
sucks,
grenades.
just go drink. And it
Free.
gets better. So
Costs a lot of money. Go drink it.
So free booze over there. So current response, there's sort of 2 main schools of thought, right? The first school of thought is that you shut down your network, you cut off access and you start rebuilding, right? That's pretty standard. A lot of books have it. Then the thing that everybody actually does is the whole rebuild while you're online, because nobody can afford to shut down a network. It costs too much money. We have some slides about that, but they both have some pros and cons, and the thing that we came up with was, well, they both kind of suck because there's too many cons to both of the methodologies. So we had to find a better way to do business. So our method sort of really goes to those cons that we had on the previous slide. If you cut off your network, your users can't work, and that costs a lot of money. If you don't cut off your network, then the bad guys keep working on your network, and they start stealing your trade secrets and your stuff that you don't want them to steal. So we came up with a way to keep your network operational, but deny the adversary, any sort of movement and ability to, steal your stuff. There is a little bit of upfront cost, but we'll show you that it's completely offset, if and when you have a problem. So we have a couple case studies. The really important thing about this really big and nasty slide is that it's really expensive to do response. The numbers in 2006 was average $4.7 million for cleanup on a network the size that we're talking about. In 2008, it went up to 6.6 million, so it went up by about $2 million. Could be as high as 32 million was the highest one reported in 2008. So obviously no numbers for 2009 yet. One of the things that the studies really showed was that employee downtime and customer inaccessibility really costs about, it could be at least a third of your cost of doing these types of things. This is a case that Aaron and I both worked on back in 2007. It cost $7 million to repair a network of 1,500 users. It was down for a week and a half, or 2.5 weeks, sorry. As you can see, 4.5 million of the 7 million was user downtime. Case study 3, this is from a thing in early 2008. So we proposed retry to a group that had a problem. Estimated cost was about 3 million. We never got any numbers back from them, but we broke it all down for you guys who want to download the slides later. They'll be on our site. Like I said, we're going to be way behind. So sorry the slides aren't bigger, but this really goes to show sort of the time frames involved with this. If you see sort of in the middle there, where everything gets kind of close, you can't really see anything. But that's where like all the actual like downtime is involved. So up front, you have your upfront work where you're developing your COOP plan and you plan for this. And then you have sort of your compromises detected. And if you plan for this and you know what you're doing, you can realistically have your network back online, operating fully, sort of, but safely in about 3 to 7 days, really. And then the whole investigation and recovery aspect that normally takes a lot of time and weeks, you don't really have to worry about because your users are back up and running and the bad guy no longer has any access. So we'll just jump right into the phases. So the preparation is kind of big on this. There's a difference between like traditional COOP and cyber COOP, right? Traditional COOP, you're worrying about natural disasters, planes hitting buildings, things like that. So you have to have separate buildings and off-site locations and what have you. With cyber COOP, you use your same building, you use your same network, but you got to have offline backups, things that won't be infected. So just keep that in mind. Not that you guys wouldn't think of that. There's obviously some resource considerations when you do this. There's the basics: identify your people. Hardware, you're going to need. You're going to be running sort of. You're going to need to repurpose some servers for temporary purposes. We think that there are a lot of trade-offs that you'll probably be able to make, so this won't be too hard. The biggest cost is going to be the software. So we're using some. We have some different suggestions here. There's others out there. But you're using some sort of like Citrix-like software to turn infected machines into dumb terminals. So Citrix, $350 a person, all the way down to Quest at $100 a user. Obviously, these are negotiable. This is just list price. And there are other tools out there, but we just thought we'd pick a couple of the commercial ones. And then your incident response tools, right? So if you don't already have something, some sort of enterprise tool, you're going to need to go out and find something or download CodeWord for free. One thing to keep in mind, all your traditional network admin tools can be really useful in a compromise. So, SMS, while it pushes packages and does updates, like it can also remove software, it can do other things. So, leverage things that you already have in place to administer your network. User notifications and training packages will be huge because you're going to basically change the entire way users interact with the network. So having all that like pre-worked up, right? You can have email set up, you can have posters, you can have flyers, you can have training stuff set up, so that when you have this disaster and you have to implement the plan, you're ready to go and you just flip the switch. I'm going really fast. I'm sorry. Slow me down if you need to. But we're getting to the better stuff soon. Architecture. The really big key on this slide was just virtualization really helps, right? So if you're using some sort of VMware-like technology, you can fire up servers a lot faster to do some of the stuff that we're talking about. And then this is huge. You wouldn't believe how many times Aaron and I have both done incident response when you show up on a network and they don't know what their network looks like. They don't have diagrams. They don't know different interconnections that may be there, trust relationships with other partners. Inventory is huge. Like, how do you know that you're done with your cleanup if you don't know how many assets you have? So, just generic health and welfare of your network type stuff, having good inventory and having good control over your network will help in a disaster. So phase 2, this is damage assessment, just the basics, right? So this is where you detect that you have a problem. So to determine if retry is going to be a good option, you're going to have to do some basic incident response up front. How big is the infection? What type of infection is it? Is your AV detecting it? Is it not detecting it? Probably not. Where are things beaconing to? Where's command and control being done from? You're going to have some of this basic stuff up front before you want to initiate retry or really any other response. I mean, it's just the basics that you do up front. So the biggest thing that really comes into play with retry, in our opinion, is the scale of the infection and whether or not you have sort of those critical backups that we'll talk about in a little bit. And we sort of already put it here on the slide, but domain controllers, your exchange servers, all your really critical like core network devices, right? You're going to have to restore these things, and you're going to need obviously backups from prior to the infection. So if you didn't detect it for months, and you may have problems. If it's only been a few days, maybe you've got tapes. So without critical backups, your retry is really not probably going to be the best fit for you. So the first step, once you decide that you do want to use retry, is obviously to do the sort of the thing that everybody recommends. Cut off all access to the network. This is where you start to use that, notifications that you've already come up with. You're obviously going to have to talk to any sort of senior management because they're going to be freaking out why they can't get to CNN and ESPN and their email. But explain to them that you're keeping them out of jail and out of the papers. So I did all phase 1 and 2 really fast, and I apologize because of the compressed time schedule. But phase 3 is kind of where it gets kind of sexy, and then Aaron's stuff is even better. So this is where it starts to get good. All right. So the whole concept of this relies on the idea that you're going to run 2 completely parallel networks for a short period of time. And we wanted to lay out some basic technologies that are going to help this work. So I don't know if anybody's familiar with VRFs or virtual routing and forwarding, right? So that'll basically, just to boil it down, you can have multiple copies of route tables on your routers. So the coolest piece about this is the idea that you can have this, like the same IP in different segments, and your router knows it basically will tag the packet with which VRF it's in, and so you could have the same mail server on 2 parts of your network, and it knows where things go because the packet gets tagged. So you take VRF, and to do it really enterprise-wide, you're probably going to do it through MPLS. So since we're talking about generically here really large networks, you're probably already running these types of things. But so to really kind of boil it down, you take switch ports and assign them to VLANs, right? The basics, your CCNA stuff. You take your VLANs and map them to VRFs, and then your VRFs, you get your MPLS labels, and that enables it to work on a big, huge enterprise scale. But what you're going to end up doing, you're going to create 2 separate networks with 2 different, like really large VRFs. So VRF number 1 would be like your quarantine network. So this is your existing network. This is the network that's just gotten pwned by somebody or some virus. So you would drop whatever section or entirety of the network, it depends on how big the compromise is, into this QNet, what we call it, a quarantine network VRF. And then you basically establish an entirely new VRF, which we call the clean net, And it basically can mirror the same IP space. So as you begin to restore services, you don't have to worry about firewall rule sets and IDS rule sets, things that are already set up for your current network. You just basically move it all over to this other network and then change. Basically, your internet connectivity goes to the clean net, and you cut off all access from the QNet. And we'll show you the diagram here. So you have your QNet over on your right, and the QNet's over on the right, the clean net's over on the left. And what you're essentially doing is you take, like I said, you just take all your compromised machines and put them in the QNet. You start restoring your services from backup tapes into the clean network, and then as you identify, compromised hosts and remediate them by either reimaging or doing whatever you do, then you would reassign them to VLANs in the VRF that's for the clean net. And then the one sort of cool thing that we're doing is you take that cluster application, streaming environment, whatever you use, Quest, Citrix, whatever, and you put it over in the clean net, and so you end up turning all of your QNet devices that are sitting there infected and trying to talk to the bad guy. They just become basically dumb terminals, right? The only access between the two networks is to that one cluster, and that's it. And so the malware can't get out, the bad guy can't communicate with it, but your users, when they log into it, they get all their basic applications. So we already talked about the QNet, but you'll have to keep an operational network running. So this is why I said you're going to have either repurpose some hardware or maybe have a few extra, whatever. You may have to have some extra devices laying around. So you have to keep running DHCP and DNS and all the basics to keep this network up and running. Because you're going to continue to use it like a network so your users can get in and out through the QNet out to the CleanNet, and for you to do the incident response piece. The CleanNet, like I said, is where you're restoring everything to. This is going to be your new enterprise. And so everything that gets moved in there gets live IP addresses. It communicates with the outside world. And as I said, since you can run the same IP address in multiple segments through VRF technology, you can have all your firewall rules and IDS rules and whatever working in the CleanNet, and you just have the QNet completely cut off. So we glue it together with just basic firewall rules. We recommend using some sort of two-factor authentication to hit the cluster that's in the CleanNet. Smart card, RSA, biometrics, whatever. Maybe you have it, maybe you don't. Just something that would be good. You can easily turn on encryption, so everything's encrypted. How do you get your clients there? So you can use SMS to set it, or whatever tool that you've got, set home pages, or you can do DNS poisoning. You can either poison the entire internet to that one host, or you can have something set up where it's the default home page in everybody's machine when they boot up the next morning. And then everything else can go to a tar pit, right? So you can then black hole everything else to some sort of a sensor that you're starting to look at. So on your cluster, right? So this is where all your users are now being driven to, no matter what they click in IE for the most part. They're going to have some applications. The idea here is this is short term. This is just long enough to figure out what happened and remediate and get them back up and running through normal means. So we're just really looking to provide the basics, email, office type applications, some sort of a web interface, whether it's IE, Firefox, whatever. Any other really critical applications. So a lot of companies rely on something like Remedy to get a lot of things done, or some other SAP, whatever you've got that's critical to your business. You're going to have to publish that out to your application cluster. Obviously, for anybody who doesn't work in it, but streaming video and things like that don't work so well on Citrix. Kind of sucks. So you're not going to have a lot of cutesy video stuff that works. And any locally installed applications on your end user host that rely on the internet to work they won't have any connectivity. So it's just something to keep in mind. So since the cluster is the only thing that interacts with the quarantine network, the dirty network, how do you want to secure it? Just some basic stuff. Obviously, you don't want to allow copy and paste, device mapping. As we already said, having two-factor authenticated sessions. Enforce any sort of DEP or no execute type stuff that you can on that client. You're essentially turning your end user workstations into dumb terminals and locking it down as much as possible. And then the biggest thing, so restoring, Active Directory and other things, right? Not too hard. You got backups, so you restore that stuff. People may lose a little bit of email, but you can scan that and bring it over. But the hardest part is going to be restoring your file server, because you don't know if the file server is where the infection happened. Maybe it's a PDF that came in through email and they saved it off. So the idea would be to restore from last known good, obviously, and then basically you got to take a chunk of anything that's been modified or created since, and obviously malware can do timestamp manipulation. So you have to make some decisions about what you're willing to accept, like what level of risk. But take those files that have been modified or changed since the intrusion, and then run them through some other tools before you bring them over. Moist from Microsoft converts all your old Office document format, the binary format, into the new XML, which is a lot more safer. So it's going to cause any exploits that are in there to crash the conversion process, but in a safe way. Acrobat, we'll get into that later. This is a disaster. Obviously, you probably want to not move any executables. Just talked about Moist, but DEP, data execute prevention on Windows or whatever, enabling any type of ASLR or anything like that, helpful. PDFs. Saw a great little ad from Adobe the other day about how they've opened up Washington, which is just kind of ironic. But so maybe look at a different PDF viewer, since Adobe seems to have a lot of vulnerabilities in it lately. Foxit, still has vulnerabilities, but nobody targets it. Restoring user services. Talked about some of this already, but one of the things that you're going to run into, the biggest challenge is going to be your users are going to have. They have locally installed applications, right? They have Word, PowerPoint, Excel, whatever. So using your administrative tools that you do to admin your network to remove those things. So uninstall Office Suite, right? You don't want somebody walking in on Monday after you've done all this work and start creating documents that they're saving off into this quarantine network that you're not planning to move any data from. So take all those options away from the user. So when they get there, all they have is like an IE icon, and it points to your cluster. And then obviously you got to get some training out to the users. And if you've done any of the prep work ahead of time, then it's ready to go, and you just fire it off. So next step, this is where we start. Really, once you've sort of restored services, using all the different stuff that we just talked about, that's when you jump into sort of phase 4, which is next, which is where you start doing the sort of in-depth analysis, right? So what was taken from my network? What do I need to worry about? Do I have trade secrets that left that I'm going to lose competitive advantages, over? Do I have, regulatory implications like HIPAA, SOX, whatever? You've got to identify that stuff and hope to God that you're not, getting your CEO fired, things like that. So that's where I'm turning it over to Aaron. Talk about phase 4 and his tool that he wrote.
So I'm Aaron. Thanks everybody again for coming and skipping out the Dungeons and Dragons battle outside to see our talk. So we're going to talk about phase 4 of the retry methodology, but really it's kind of about code word. Just a funny little story. I'll give you a little background on the tool because it's been such a pain in my ass for the past 6 months. So like back in February or so when Presmike came to me about the idea for this talk, I had a tool in mind since we had done work together in the past, and we had done incident response efforts and all this kind of stuff. And so I had an idea for this tool, and unfortunately, there was this thing with a past employer of mine that I didn't really take very seriously. And I guess in between jobs, I spent about 6 weeks working on this tool to go into the talk. And we submitted it to Black Hat and everything and got accepted. And so I guess that came to bite me later on. And 2 weeks before Black Hat, they're like this whole snafu blows up in our face, and barely get the talk approved for Black Hat, but we couldn't release the tool. And so then for the next 3 months of my life, I spent fighting trying to get this thing released. And just a couple weeks ago, I got the final letter. And once you download the source code and take a look at it, you'll be surprised what's the big deal? Why was this such a big deal? So if you can figure out why it was such a big deal, please let me know, because it's really not that complicated. The whole idea behind the tool is to combine things that are out there, like methods, techniques, that are out there in tools that may not be combined into one tool. Well documented, there's been books about this. A really good one is Undocumented Windows 2000 Internals. If you don't own that book, you should buy it if you're interested in like rootkit stuff. Tons of stuff on rootkit.com, tons of articles on uninformed.org, FRAC, a lot of publications out there that talk about this type of stuff. There's even tools. Most of them are not open source, although they're free, things like iSword and Gmur and things like that. So the idea with CodeWorks is kind of put that in one tool, make it network aware, client, agent type, administrator console, connect to an agent, pull some results, do some queries, maybe attach a little remote debugger to whatever you're looking at. So there's a lot of ideas that are in this tool that may not be implemented. And since I haven't really looked at the code in about 4 months because of all that crap I just told you about, there may be lots of bugs in this. So it's freeware. It's maybe crapware. I don't know, but just download it, add stuff to it, whatever. I'm gonna put it on Google Code tonight or tomorrow sometime, and that's kind of my goal is to get this out there so you guys can like add stuff to it and make it a good tool. Because right now it's decent. It's like a framework that you can use to put stuff in there. So anyway, that's the idea. So back to this phase 4 thing. So when you're in the response, the response phase, it's the typical SANS process where you do your identification, containment, eradication, and it's like cyclical, right? So that's the traditional phase 4 process. Lots of commercial forensics tools to do this. The problem is they're very costly, they're complicated, miss the edge cases, the easy stuff that you as a network defender or as a system administrator would be first on your mind. It's like last on their list. And they have a lot of this forensic, like I refer to as the F word type stuff, that they wrap all their capabilities in, so it makes it even harder to use the tool. And there's also other enterprise like security tools you can use, like AV scanners, host intrusion prevention systems. Mike mentioned some earlier that you should leverage in your normal response effort, but they're not what you would call an all-encompassing like forensic or incident response tool. There are some open source tools I also mentioned, but basically, my frustration as an incident responder was I need something to get the results in like a week or 10 days, not 6 to 8 weeks, however long it takes most of those commercial tools to get the data back. So the idea here is there's this little tiny subset of critical information you need to get out of a host to determine whether or not it's been compromised. Just real simple stuff like disk indicators, memory indicators, and registry indicators. The details are listed there. There's a big push in memory forensics over the past 4 years, so a lot of interesting stuff to do there. Some of the stuff's in the tool, a lot of it's not, but again, with the help of the community, we can put it all into this tool and make it really useful. So the idea, again, is to get this critical data represented in a meaningful way, securely, and so the analyst or the network defender can come to a reasonable conclusion about the state of that machine. A little bit more about the frustration here that caused me to write yet another tool out there, right? So bugs in commercial forensics tools. I'm not going to list any names, but if you've used the tools, you probably know which ones I'm talking about. Wasted times working with a lot of wasted service calls, licensing problems, inconsistent results, crashes. The GUI is real bulky. It's hard to use. These are a lot of common complaints with software development in general, but they seem to be particularly bad with forensics tools. I'm not sure why, but. So again, we mentioned all these things you should be using as an incident response person or like a system administrator person who's really on top of your security game. Think of CodeWord as kind of like an AV scanner because you can create your own signatures and deploy them. But it's also like an enterprise forensics tool, even though it does not claim to use forensic, like forensically sound manner or anything like that. It does have the capabilities of forensics tools. So malware evidence collection, building up case studies, generating reports, things like that. And then your rootkit detection edge. So again, these are the I guess the broad capabilities that it has right now. Some areas are stronger than others, but your detection, evidence collection, reporting, mitigation, and remote analysis is probably the coolest like techie part. So signatures are pretty important to the tool because you may have a reverse engineer on your team, or you may be pretty good about picking apart malware and finding out what makes it tick and how you could detect it. So just some basic, some really simple signature logic to write your own signatures, deploy them, and look for those evidence of those signatures out on hosts. And the cooler stuff, I guess, is the advanced heuristics, right? So this is the rootkit detection stuff. It doesn't really have any low-level heuristics right now. Like at the time, that was on the to-do list, near-term to-do list, but it didn't get to it. So the user mode and kernel mode stuff is there, at least some of it. And the low-level stuff, anybody wants to write like a BIOS rootkit detector, like that'd be awesome. Come and see me and tell me how you're going to do it. But so again, receive usable alerts. So a lot of the SIMs, the security like information management tools that aggregate all this crap, they present you with a lot of alerts, but they don't always make sense. Sometimes they're outdated, they're unusable. So the idea with CodeWord was to kind of present this in a very simple way. These are some sample uses. We're kind of like really out of time here, so I'm going to blow through this, but just some caveats. This is again freeware, so don't come emailing me if like it crashes or blue screens your box or anything like that. So these are the three main components of the tool. All the user mode stuff is written in C#. It has the administrative console, which is what you'll probably use if you're like the investigator. That's what you'll see most of the time. It's a graphical interface that allows you to create new agents, wrap them in an MSI installer. It does not do deployment, so you have to use whatever existing deployment mechanism you have, like SMS or PSExec, Altiris, whatever software distribution management system you have. You just throw this in there and it'll silently install on whatever target you want to investigate. The actual agent that's inside the MSI installer is also written in C#, and it does all the scanning and the communication with the kernel mode driver, which is written in C. This is like, I'm going to throw the GUI up here and just basically show you like all the nefarious steps here. So the idea is you create an agent, you wrap it in this MSI installer, you deploy it, and then you connect to that agent, start your scanning, your analyzing, things like that. So that's not working.
There you go. The other way.
Wow.
It's too big.
Too bad this resolution is not going to make this very usable.
Just show the first half of it. That direction.
All right, so you're missing about a fourth of the screen here, but we'll do our best here.
There's nothing on it.
Right. So this is basically, there's three main tabs. This is the admin console again in C#. So you're going to navigate these three tabs most of the time. This is where you connect to existing agents that are deployed. These will be like basically all the capabilities you have. This is where the results are displayed here. This part's not implemented yet. Basically, the enterprise pool is for when you create an agent in fire and forget mode, which I'll get to in a second. But basically, it's a way to aggregate a whole bunch of results from like thousands of hosts that you may not want to connect to individually and pull results from. So there's a whole slew of settings here I've come up with. Most of them implemented, again, some of them not. But these are the three like main modes of operation. Enterprise mode will run the scan that you've configured, open a listening port for commands so you can connect to it and do more deep dive stuff. Remote control mode is the same thing, but it doesn't run the scan initially. And then fire and forget mode is basically you want to send out like 1,000 of these things, have the agent unpack, install, run the scan, collect results, wrap them up in a zipped archive, and send it back over. Like I think the options are a web share, SSL server, SSH. There's a couple other methods that you can have it automatically like drop a zip file of all the evidence it found in the report. Self-protection is not implemented. This is kind of like before the agent like unpacks and starts scanning, load the driver and look from kernel levels, see if you can find any anomalies, and if you find something, don't do anything. Connection, these are settings for the agents like listening port. CodeWord is PKI compliant, so it uses certificates in the form of the PKCS12 format. So you give it a PKCS12 file, the password, some various strong authentication options here if you want to use that. Most of the persistence is implemented. The stealth is not. This is cool stuff I had, ideas I had that I wanted to do that are documented out there again, but I just haven't got to them. Mitigation is what you want to do when you find bad things. So these are all implemented. These are basically like configure-like things. So this was happening at the time when I was writing the tool. Collection, offline analysis is not implemented. So this is like my memory forensics kick. So rather than doing things through API calls to the operating system, you may want to just take a dump of memory and try to carve it out yourself. There's a whole lot of tools out there for extracting all kinds of useful information out of memory dumps, like redraw an entire like desktop based on like Windows objects that are stuffed in memory somewhere. So there's some really interesting research out there that you could use rather than relying on operating system that may be lying to you. This is the reporting is for it's for fire and forget mode. So if I go over here and select fire and forget, I can select all these different methods to report back the results, and it can be encrypted at the authentication at the application layer as well. Organization information, some advanced stuff. This is all implemented. So if like you want to run like an AV update after you do the scan, you can embed the AV update signature file in here and have it run after the agent runs. So the two useful things the agent has, these are the signatures and heuristics. So with signatures, there should be a fourth tab here that I never got to, which is network. So like open sockets, things like that. We'd also be able to write signatures for that. But as it stands now, these are the three we have. For the registry GUIDs, these are basically every application that installs in Windows has a GUID, especially if it's like a COM server or something like that. It's going to have this unique identifier that every registry key that references that application, it's going to be in the registry tree, it's going to be embedded under that GUID. So you got to know at runtime what the GUID is for this malware. So you can define those GUIDs here, and then reference them here when you define registry indicators. So let's say a piece of malware, when it installs, it gets a GUID, and it creates like 4 registry keys that it uses to reference later, whatever operation. If it's like a URL that it's going to beacon out to, sometimes they write that to a registry key. Well, that could be an indicator. So you define that here. You'll probably know the GUID ahead of time. Either you reverse engineered it, or it's out there on like PrevX or McAfee or one of those other sites. So you stick that, you create that GUID, stick it here, reference it in your registry keys, and create a whole bunch of registry indicators. And then a useful thing is to like export your signature, create a signature template for like whatever malware you're looking at, if it's Conflict or Storm or whatever, and then you can reference it later. File, these are pretty simple stuff here, like file name, size, a hash, MD5 or SHA-1 hash, what you want to do if the file is found. And the PE signature is something I created for kind of just like a 16-byte, like I don't think it's 16. I don't even remember how. I don't even remember what it is. I think it's like a 52-byte signature I create from like the NT header structure of a PE file. So something like that would be unique to that binary if you found it on the system. This would be really intensive to search for this. So anybody that has good ideas on how to optimize that, good. So memory, basically you define an action. You terminate the process if it exists. Terminate it if there's a keyword found. So by keyword found, that means is the keyword that I specify here found in the process heap space, loaded module list, or a command line parameter when the process was started. So a lot of malware, like if they do like a run DLL 32 type piece of malware that launches a DLL, it'll have a whole bunch of parameters in the command line string that would be useful to identify it in memory. So those are your signatures. Really simple stuff, but we found it to be really useful. And just quick indicators of infection. The heuristics, a lot of this stuff is not implemented. In fact, most of it's not, but these are all ideas that you guys can contribute to. Like process and thread stuff, hidden processes. A lot of stuff can be done here with modules that I did not list here. Again, keep in mind I had to take a lot of stuff out. Okay. Browser helper objects and toolbars. Probably like 60% of malware will install some type of helper object or a toolbar to annoy you and to like gain persistence on the system in user mode. All this stuff is implemented except for the IDT. These are all heuristics from kernel mode that the driver runs. Drivers, you can specify any drivers that are loaded in the kernel that you may want to inspect for like ERP-hooks or driver dispatch routine detours. Basically, if a piece of malware, there's some malware out there like Midgebot that will patch like the first 20 bytes of a function prologue to like redirect its whatever capability, whatever the function does, it'll redirect to that hooking function. Do something different and then basically redirect back to the original function. In this TDI, low-level network driver stuff, not implemented. BIOS and boot sector, not implemented either. So anyway, that's the heuristics. So once you specify all your settings, and you click Generate MSI. It'll drop an MSI to disk. You'll deploy that out, and then you'll connect to an existing agent. So since we're like pretty much out of time, I'm just going to run the demo. So I've got 3 things I'm going to do in the demo. We've going to infect this machine with Stormworm, first of all. And luckily, that's as simple as double-clicking this file. So I think this is a binary we got from somewhere, like in an email attachment, phishing it, some type of like scam or something. But you just double-click it.
You should go to System 32 to show it.
Yeah. So so it drops this sys file here, which is a tiny little rootkit, and peers.ini, which is the list of nodes it beacons out to. So these are the 2 files we're going to look for. So that's the first thing we're going to do. And then just to show you that the process thing works for memory. So I have a calculator running here. I'm just going to detect the calculator's running and then to terminate it remotely. And the last thing, I'm going to use this little tool here to start an ERP-hook rootkit. This is like a proof of concept rootkit. You can get off rootkit.com, the source code and everything. It's real tiny. All it does is hook a few dispatch routines in the TCP/IP.sys dispatch function table. That's a mouthful. All right, so I'm going to start the agent up. Normally, this would all be automatic, so you would deploy the MSI, it would install silently, and then it would kick off this command here. It would just launch the agent. And all this crap would debug information would not be there. Okay, so it installed the agent, checked to see if the driver was on disk. If not, extract it from the agent, started a driver service, and we're good to go. So I'm going to go ahead and start service already exists. All right, I'm going to start the rootkit so it's operational. I've already started Stormworm and calculators up and running, so. Yeah. All right, so basically you just pop in the IP address you want to connect to. Over here, which on the right, you specify like the PFX file for the admin console because it's mutually authenticated. All right, so that's done. Click connect. There's this little progress bar over here. All right. Apologize for this resolution issue, but basically you get a whole bunch of information here about the host, about the agent, what version's running, version of the signatures, a whole bunch of other crap. It may not be worth showing here, but yeah. All right, so we're going to kick off the scan. And it may take a little while because it has to scan disk and memory and registry, looking for these various things. And hope it doesn't crash, because again, I haven't looked at this in about 4 months. Other than today, where we were frantically trying to get it to work. Can everybody hear me? Awesome. Grab a beer or something, or hand grenade and wait. What? I feel everyone's angst. Sure, yeah, I have a small little library I've been building as I've been testing it, so I'll post those along with the source code. This is going to be on Google Code. The website, if everybody's about to leave, the website's code-word.org. Probably tonight or tomorrow I'll post everything, and please download it and let me know how much you hate it.
Please work use.
I'm sorry? Yeah, I'm sorry, did I not make that clear? This is the admin console. Yeah, this is the first program that I was talking about earlier in the slides. The agent was what I ran from this command prompt here. This is the actual agent. Normally this is installed as part of your deployment. It'll install automatically on the host. Normally you wouldn't have to do this part. You never really see the agent.
All right, show results.
Okay, so here are the results. So we have the registry findings here. Stormworm writes an entry for its driver in both these places, current control set and control set 001. It found the INI file. I'm not sure what you mean. What do you mean? Oh, it looks like XP, don't you say?
Oh, that was the system information.
Yeah, that was the system information I pulled from this host. Just to show you guys what the signatures were, all it was just a file name. So when I created these signatures, the action was deleted found, pierce.ini is the name. So I knew this malware dropped these two files. I wasn't sure where, or I didn't care, but I just wanted it to try to find those two files. So it found them in these locations. This is the hash, the creation date, and all that stuff. All right, so we found calc was running. So the next two things you want to do after you run a scan is to collect the evidence and then do the mitigation. Yeah, I'll get to the RPOK.
Okay. Oh, you're going to pull.
So first thing I'm going to do is just like, I'm going to kill this process because I'm an analyst and I want to do something manually. So I'm going to pull it up over here, and then I'm going to click this mitigate button. Says, are you sure? Okay, yes. All right, bye-bye. Calc just went away. I can also delete these files on disk. Yes, delete them. All right, they're deleted, so let's go make sure they're gone. Hopefully, yep, they're not there anymore. There's pierce.ini and Win32. All right, registry, same thing. We could delete the keys. This is a list of active processes running. All right, kernel mode anomalies. This is kind of your rootkit detection stuff. So again, we installed the RPOK driver. So code word is telling us that the device driver named tcpip.sys in the kernel is being hooked. Its dispatch function table is hooked for the ERP major code device control. And this is like one of the main ERP major function codes for all drivers is device control. So obviously it's a good place to hook. It's being hooked to this address, which is the Win32.Win32com, or whatever Stormworm names its driver. That's where it's loaded in kernel memory. The anomaly is a hook. RPOK.sys is the module. This disassembly column would be populated if it detected a detour, which since this is basically when you're validating, pretty much all of rootkit detection is about validating pointers. So you look like Windows is notorious for having tables everywhere, tables of pointers, and pretty much a rootkit will install a hook by overriding a pointer somewhere. Some legitimate pointer function that Windows has, the pointer will be overwritten to point to the rootkit's function. So it's just a matter of going in and validating that these pointers point to something inside a module it should be pointing into. So if it's an NTOS kernel, like the Windows kernel, if it's a function that should be there, but it's pointing outside to some other module, for example, like the kernel is usually loaded at like 8,000 or something. Since it's not pointing there, obviously that's a bad thing. So if it was a detour, we would see like 50-byte disassembly here of what part of the function was being patched. So in a detour, it's not overriding a pointer. It's overriding a chunk of bytes in memory for whatever function it's trying to hook. So basically the way you detect a detour is you read the first 50 bytes or 5 bytes or 20 bytes or whatever and look for a jump or a call or some other type of x86 instruction that would redirect execution to some other module. So Windows does this with hot patching. They'll have like a 5-byte stub at the top that'll jump into whatever patch code they have. If that module has a bug or that whatever Windows driver has a bug, they'll patch it using a little hot patch. And so actually Microsoft has a huge detours library for this. They have source code and everything you can download on how to write your own detours. So that's it. I guess that's all I have time for. Probably already over. So any questions? What's up? Right. Yeah, No, it's not like a proactive thing. It's like it goes kind of like with a retry. It's like an instant response methodology tool. So like you think you've been pwned, you want to like look at your hosts on your network and figure out